Hello guys, welcome to my channel, WebGR of Talents. And by now you might be wondering what are we gonna learn in today's video. So I don't want you to keep waiting. So today we'll be learning the chapter Matter in Our Surroundings. We won't be learning it exactly, so let's look at the most important MCQ questions in the chapter. So this is our first question that we have here, and let's start reading the question. CO2 can be easily liquefied and even solidify because. So the question here is asking the gas CO2 can be easily liquefied. We have read these terms many times in the chapter, and even solidified. So liquefied means to convert gas and the CO2 into this liquid, and solidified means to convert the liquefied CO2 into solid, or we can directly convert this CO2 into the solid. So this is what the question actually asks us. And then let's start reading the options now. And here we have the option A. It has a weak force of attraction. Then the option A, it has weak force of attraction, means that the molecules present in the CO2 compound don't have a proper attraction force to attract each other molecule. So they are far apart from each other. And we have the second option, option B, and let's read it. It has a comparatively more force of attraction than other gases. So here we know that the force of attraction is more in CO2. This option says that the attraction of CO2 molecules are more than any other gases present. And option C, it has a more intermolecular space. So the spaces between the molecules of the compound of CO2 are high than any other compound. And that option D that we have is, it is present in atmosphere. So this option, by reading itself, we can say a direct no to this, because we cannot prove that CO2 can be easily liquefied and solidified because it's present in atmosphere. It's relevant but not useful in this place. And the correct option that we would be having here is option B, and it has a comparatively more force of attraction than any other gases. So we have already known in the lesson also that, I'm telling you once again, CO2 gas, okay, has comparatively more force of attraction than any other gases. So this is a pretty much important point for us to understand. So let's hop on to the next question and solve it. So this is our second question, and let's start by reading this question. Which of the following has highest kinetic energy? So I know that you know what is kinetic energy. We have read it a pretty more times in the chapter. So if you hadn't remembered, just don't get worried. I will give you a link in the description and you would know everything about kinetic energy. So here it's asking that in the given option, which of them has the highest kinetic energy? And let's start by reading the answers. And option A is particles of ice at 0 degrees. So it's obviously true that the particles of ice or water will be ice at 0 degrees Celsius at any cost. Then we have the second option, particles of water at 0 degrees. So these both options are both the same. So it will be at the position of latent heat of fusion. And then if we look at option C, it's the particles of water at 100 degrees Celsius. And then we have the last option, particles of steam at 100 degrees Celsius. And even these both options are same. But there is a small relation. We have to compare between these both. We can together say that these both are equal, but if they ask us which is the highest among these two, then we can say this. No, we cannot say this as the correct. We should say water, because the latent heat of fusion depends completely on the temperature or the heat present in it. So ice would be more solidified and would be more little cooler than water. And then if we look at this also, what we cannot take it as water, because water would be just little less heater than that of steam at 100 degrees Celsius. Now we have cancelled these two options out from our list. So the things which should be compared now are these two options that we have here. So one is the particles of water at 0 degrees Celsius and other is the particles of steam at 100 degrees Celsius. By looking at them, what is the obvious answer that you have in your mind? Just strike this off. And option D is our correct answer. Particles of steam at 100 degrees Celsius. Because water is comparatively very less heater or hotter than that of steam. So, if you have any doubts, don't get worried. Let me know in the comment section and I'll clear your doubts as soon as possible. Please like, comment, subscribe, share to my channel with Jar of Talents. Thank you for watching the video. Goodbye.